Now, hi everybody. We're going to start a new section now with you. I'm going to do oxidation and reduction. Everybody should have a copy of that now, and you should have a copy of your notes with you. If you haven't, will you pause this video and go and get them? They're an attachment to this video. All right? Good. Now, we'll start with an introduction. Just take a look here at what we have to deal with. We're going to do a definition of oxidation and reduction. There will be 5 definitions in all in this section. That'll be a unit in itself. And then we'll do oxidation numbers, which is a technique used by chemists when they want to basically interpret more complex chemical reactions, and it's governed by a set of rules. And of course those rules have exceptions, and we're going to apply them then and use them as they would appear in the exam for you. So that'll be very important. So I'm going to work my way through that in sequence, and I'd ask you to be attentive to it. Now, there'll be quite a bit of board work today. So will you just be aware, please, of having to write material and to kind of repeat some of the work I've done with you. Now, when I get to the end of this section, I'm going to look at some exam papers and how this is applied. There's a very reliable unit in the Leaving Cert exam on this, and you can get all the marks in it. It's one of those where you have a lot of control over it. Just checking my images that you're okay, you can see everything. You can? Okay. Now, will you be aware, please, that we have 5 definitions for oxidation and reduction. Now, before I start, let me classify chemistry for you. Do you remember in an earlier class that we did acids and bases, and I told you at the time that there were actually 6 subdivisions in chemistry, and they're broken down then into 3 major units. The 3 units are reactions where protons are transferred from one substance to another. That's called acid-base reactions or neutralization. And then there's a set of reactions where electrons are transferred from one section to another, and that is known, of course, as redox reactions. And then there's the 3rd unit of chemistry, which is the rest. So you have acids and bases, you have oxidation and reduction reactions, and then, of course, finally, you have what we know as just general chemistry. Much of it would be organic chemistry, by the way, but that's another unit that will be done in due course. But we're dealing with this one now, and it's clearly defined on the paper, and it would be very, very important that you'd recognize where we're going with this. 5 definitions for oxidation. You might say, why? Well, there are different types of reactions, and we need to know how we survive with this now. I'm going through them briefly with you now. Oxidation is the addition of oxygen. So anything to which oxygen is added has been oxidized. That's the origin of the name, by the way, and that's fine, okay? Or it could be the removal of hydrogen. If somebody removes hydrogen from something, then it has been reduced, okay? Or a loss of electrons. Now, I have an asterisk on that one, and in your notes it's double marked because it's very important. If you're asked in Leaving Cert to define oxidation, please define it as a loss of electrons. Why? Because everything has electrons, and therefore it will cover every case, right? Number 4 is an increase in oxidation number. Don't worry about that for the moment now. I'm going to go through that in the next section, so it'll be dealt with. And lastly, there, to cover every possible option, you have, of course, got an increase in valency. Now, you'll survive admirably on the 2 with the asterisks. The loss of electrons or the increase in oxidation number. You'll survive admirably on the 2 of them. And it's very important, in my opinion, that you would know those 2. If someone asks you now to define oxidation, please, you will say oxidation is the loss of electrons. Full marks. Okay? Now, I have an example there. I'm going to write it here again for you now. Magnesium plus oxygen goes to magnesium oxide. And basically, what I'm suggesting to you about that is the magnesium has been oxidized. And you're going to say to me, big deal. You know that anyway. You're adding oxygen to it. So the magnesium has been oxidized. But that's very important that you recognize that. Okay? But wait a moment. Supposing I wrote it like this. Magnesium plus chlorine gas would give you magnesium chloride. The magnesium has still been oxidized. So can you see that the first definition will leave you down? It will not be very reliable if there isn't oxygen involved in the reaction. And that's vital that you're aware of that, okay? So oxidation is the addition of oxygen, okay? Or, I've said there to you, the removal of hydrogen. There's no hydrogen here, so you can't use that one. But in this particular instance, I'm saying to you, magnesium has been oxidized in both of them. So how do you know that? And we have to deal with that, of course, and I'll deal with it as follows now, right? Let me remove this one again for a moment and just point out the magnesium became magnesium oxide. Now, you'll have heard me referring before to the Paddy-Murphy theory, the PM theory, right? The plus at the front and the minus at the back. And that's exactly what you have there. That's Mg2 plus and that's O minus, okay? That's the Paddy-Murphy theory. So the Mg technically went to Mg2 plus. Now, let me pause a little bit there for a moment. How do I know that? Well, basically, I'm saying to you, every chemical compound has a cation and an anion. And the cations are always positive. Okay? And in this case, magnesium is in group 2 in the periodic table, so it's a valency of 2. How would magnesium then, Mg, go to Mg2 plus? And I hope you're going to tell me by losing 2 electrons. If you added 2 electrons to that, you'll get that. Okay, and that's basically what we're saying. So the magnesium has lost electrons, so the magnesium has been oxidized. Now I'm pausing there for you for a moment because that's very important, right? The first definition is lovely, provided there's oxygen in the reaction. If there isn't, it's useless. The second definition, removal of hydrogen, is lovely if there's hydrogen involved in the reaction. The third reaction is brilliant, because there's electrons in every reaction. And I've come to the conclusion that the magnesium went from Mg to Mg2 plus. Now, you might need to kind of go back a little bit there. I mentioned that previously to you. Being able to write chemical formula is based on the cation and the anion. There are only 2 parts to every name in chemistry, and that's vitally important you have that. So the Mg goes to Mg2 plus, and the Mg has lost 2 electrons, so the magnesium has been oxidized. Are we okay with that? And that's very important. Let me just repeat it then for the other one. Mg plus chlorine went to magnesium chloride, okay? And that basically meant that the Mg went to Mg2 plus. I didn't bother mentioning it, by the way, but that would have been O double minus, Mg2 plus and O double minus. And this would have been, of course, that's Cl2 there, excuse me now, Cl2 here, okay? And so that would be Cl minus. And you need 2 of them for 1 of them. Now, that's not involved here. All we're interested in is the magnesium. The magnesium has been oxidized, okay? Because it has, in this instance, Mg2 plus has lost 2 electrons. How would Mg become Mg2 plus? And the answer is it would have to dispose of 2 electrons. So the magnesium has been oxidized. Now, do you think you're okay with that? Now, that's very important. So your definition of oxidation then, technically speaking, is loss of electrons. That's the best one by far. But you can see how we have to apply it, and that's most important that we would do that. Very good. So I'm going to leave that for a moment. I've just taken a simple example of it there for the moment, okay? I'll move on next to reduction. Now, reduction, I need to tell you, is the opposite of oxidation, and it has 5 definitions again. They're all the reverse of the ones above. And I hope you're okay with that. Reduction is the removal of oxygen, or the addition of hydrogen, or the gain of electrons, or the decrease in oxidation number, or decrease in valency. And the 2 I've highlighted are the 2 in your notes highlighted as well. If you're asked to define reduction, you'd please say, oh, it's a gain of electrons. Reduction is a gain of electrons, oxidation is a loss of electrons. That's by far the best definition. Why? Because that's only useful if there's oxygen in the reaction. That's only useful if there's hydrogen in the reaction. Don't worry about the 2 down here. We're going to deal with them separately in this section. They'll be done with anyway, so don't worry about that. You'll be fine. There'll be no issue at all there. So that's basically it. No, so they're your definitions. I'm repeating again now. Reduction gets its name because it is the removal of oxygen. That gets its name because the addition of oxygen, okay, and that's it. It could be the addition of hydrogen, or gain of electrons, or a decrease in oxidation number, or a decrease in valency. Right? And I'm taking a simple example here again now. Remember, these examples will be given to you now. Okay? You'll be given the equation, you'll be asked to interpret them, and that's what this section is about. That's copper oxide, okay? Some people might call it copper 2 oxide because the valency of copper is 2 in that. Okay? Copper oxide plus hydrogen goes to metal copper on its own, plus water, okay? And you're given that now. Relax in the knowledge now that that's given to you, right? And I'm mentioning to you that as you go along, you know, they don't always balance, by the way. That equation isn't balanced at the moment. Don't worry about that. I'm only using it as an instruction. And according to this equation now, and based on these definitions, we should be able to come to the conclusion that the copper oxide has been reduced, okay? CuO, maybe I'll write it down lower for you. CuO is reduced. And why is that? Well, visually by inspection you can see that it gains hydrogen. There's an addition of hydrogen to it. So that stuff there, okay, has been reduced. Okay, now obviously that definition is no good to you because obviously in this case, even though you can visually see that oxygen has been removed from it, is the first one. Adding hydrogen to it is the second one. And that's fine, but there will be a lot of reactions where you won't have hydrogen and oxygen. So the third one is your formal definition. Okay, that reduction is the gain of electrons, and I'm going to explain that to you now. The Paddy-Murphy theory here again for the compound, that would be Cu2+. And it becomes over here copper. And the question I have to ask you, how would Cu2+ become Cu? And the answer is by gaining 2 electrons. Now I must ask you to be careful here. There is no copper there in that. Okay, that's a black powder as it happens. Okay, copper is something from which you can make a copper pipe. Okay, so that's not copper and there is no copper in it. Okay, that's very important that you realize that. That's the ion of copper that's in that compound. That's the copper ion in the compound. And so we weren't supplied with the ion, we're supplied with copper oxide. So that substance has been reduced because the copper ion gained electrons. Okay, and ultimately we say the copper oxide or the copper 2 oxide has been reduced. And they're the 2 examples you have of it now. Let me just mention a moment. This here is reduced. Okay, the magnesium has been oxidized and the copper oxide has been reduced. Now I'm pausing again for a minute because I want you to kind of get a better picture of what you're going to do. If I give you any equation, you must inspect it. And based on the inspection, you can then come to a conclusion as to what's happening here. So just be careful with that, won't you? So in this instance, the magnesium was oxidized. Somebody added oxygen to it. I've already showed you because the magnesium has lost electrons. It's oxidized. The copper oxide has been reduced. Now, I would be concerned that you might be inclined to suggest that the copper is reduced. There is no copper there. That is copper oxide, a compound. So the copper ions have been reduced, but you'll name it as that because that's the species they supplied to you. So the copper oxide has been reduced because the copper in it has gained electrons, okay? And that's ultimately what we're after, and ultimately we have to deal with that. So there are 2 definitions for you then. Define oxidation in an exam, you'll say oxidation is a loss of electrons. Define reduction. Reduction is a gain of electrons. And you'll see the mnemonic on the study plan there. You all know it, I'm sure. Oil rig. And that represents that, of course, doesn't it? Oxidation is a loss of electrons. Reduction is a gain of electrons. And that's ultimately what you're after, okay? And that's the first 2 definitions. Now, can I go back for a moment again and remind you of something we did in acids and bases? In acids and bases, we came across a theory called the Bronsted-Lowry Theory. How are you fixed with that? Do you know there are 5 definitions in that category? Define an acid, define a base, define a conjugate base, define a conjugate acid, and define a conjugate pair. Now, I'm not doing that at the moment, but I have it done with you. So go back in it, please, if you're in doubt about any of them. A set of 5, and you could be asked any one of the 5. Now, please be careful with that. It's very important that you're picking up on this and you have data. There are 5 definitions here as well. Okay, the 5 definitions are oxidation, reduction, oxidizing agent, which I'm about to do with you, reducing agent, and finally, oxidation numbers. Okay, there are 5 definitions. Now, these sets are crucial, and this first unit I'm doing with you right now requires you to be very clear on the 5 of them before we progress. So I'm asking you now please to pay attention to this and make sure it's okay. If you do, you're going to do fine with that, okay? Now the next part of your notes in that, and I'm just taking the notes to make sure you're all following it, okay, is the concept of a redox reaction. R-E-D-O-X, a redox reaction. Gets its name, of course, because there's reduction and oxidation involved. Okay, now conveniently up here I said the magnesium was oxidized and the copper oxide was reduced. Conveniently, just to keep it simple. I chose to ignore that there's an issue here. A redox reaction is saying to you that, as from your notes now, oxidation and reduction occur simultaneously. You can't have oxidation without reduction. If something loses electrons, it won't lose them unless there's something waiting there to accept them. So you get oxidation and reduction going on at the same time. Now that's very important that you have an awareness of that. Even though we often write, that's a half reaction. It's only half the story. I'm telling you what happened to copper in this reaction, but I didn't tell you what happened to hydrogen at all. And that's very important that you realize that, okay? That if the copper oxide is reduced, then the other sidekick there must have been oxidized. I told you the magnesium was oxidized, but I didn't say anything about the oxygen. And that can't happen, you see. Something won't lose electrons unless there's something waiting there to pick it up. And let me just expand that concept for you for a moment now, because it goes back to the early part of your chemistry. You must surely know that there is a property on your course called ionization energy, which is the energy you need to pull electrons from an atom. Now, where is that energy going to come from? Of course it's going to come from the substance that's going to keep those electrons. There'll be a reward for that. So when you lose electrons, something else has to supply them if it's to gain them. And that explains that, you know, anywhere something loses electrons, the electrons are gained by something else. And when you gain electrons, energy is given out. Now that bit isn't on your course about the energy that it has to be supplied when you gain electrons. But losing electrons is. You need energy to rip electrons off an atom. Who's going to supply that? If you're going to rip electrons off that, who's going to supply it? The oxygen. In other words, I suppose what I'm really trying to say to you is electrons are never running around on their own. Okay, they're never just roaming around. Things don't just shake off electrons and, you know, and leave them there. It doesn't happen like that. The electrons are lost because something is waiting to gain them. Okay, so you always get oxidation and reduction occurring simultaneously, right? And as written in your notes then, it is not possible for one to occur without the other. Electrons must be lost by one and gained by the other. And these reactions are called redox reactions, okay? And so in this case now, I'm going to leave those two on the board for the moment. Just want to leave them there for reference purposes. And I'm going to give you a very standard example for a redox reaction. If you reacted sodium metal with chlorine, you'd get sodium chloride. Okay, there you are. Now, relax in the knowledge now that every equation will be given to you. Right, and you'll be asked to analyze it. So you're inspecting here. You really don't bring much to this now, but an awareness of what you're given and what you're going to do with that, okay? And now that's a redox reaction which I'm going to identify for you. Before I do it now, can I just tell you I rather like this equation because it illustrates a lot about the features of chemistry. I'm talking about the fact now that sodium is a highly reactive metal, and you need to be careful with that, okay? It reacts with the metal, and I think you'll want to realize that it's quite reactive. If you put sodium into water, it'll react violently with the water. It'll run around the top and produce lots of hydrogen gas, okay? Giving a yellow flame. If you were to put it into acid, it would be highly dangerous. It would be explosive. So that's a very, very reactive substance. Chlorine gas is highly toxic. If you were to inhale it, it would be fatal. Okay, it's very dangerous. Those two are very dangerous substances, yet when they react together, they produce something that we all ingest. Okay, all our foods are full of salt, as you know, and that's common table salt. So two very dangerous substances becomes quite harmless. That's chemistry for you, where you transform something from one format to another, where it's highly dangerous to them, and yet that's harmless. So I think we have to recognize that, you know, a lot of equations are like that, and we have to work with that. So how am I going to show you that's redox then? Okay, let's apply the Paddy-Murphy theory here for a moment now, and then worry about, you know, if you start putting Paddy-Murphy in your exam with you, okay? I'm just giving you that as the idea. That's the plus and that's the minus, okay? So the sodium goes from Na to Na plus. How does Na become Na plus? And the answer is it loses an electron. Very good. That's what happens. And the chlorine, let me just take one of them. The chlorine goes from Cl to Cl minus, the Murphy, the minus, yeah? How would Cl go to Cl minus? And the answer is it would gain an electron. So this guy is losing electrons and this fellow is gaining them. So obviously they complement each other, and that electron, I've no doubt, is that electron there. Are you okay? And it's called a redox reaction because you can't have electrons floating around on their own, as I might suggest there. That's only a half reaction. It's only half the story. And it's very important for you to realize that, okay? That we often write half reactions, but there's another half you're choosing to ignore. And I'd ask you just to be aware of that. If you are, there'll be no issue at all, right? So that's called a redox reaction because the sodium has been oxidized. Yeah, that's oxidized. Why? Because it has lost an electron. And the chlorine becomes Cl minus, so it gains an electron, so that's reduced. So that's known as a redox reaction. In fact, they're all redox reactions, except I choose to ignore half of each of them when I was illustrating it. Keep it simple then. That's a simple illustration of oxidation. That's a simple example of reduction. And then I'm dealing more specifically now with the concept of a redox reaction. I'm acknowledging that both oxidation and reduction occur simultaneously, and that's very good, right? Now I have that on the screen there, but I mean I just need you to look further at it to see it's okay. Yeah, but the sodium and the chlorine reacting with sodium chloride. The sodium loses an electron, the chlorine gains the same electron. So really what happened is an electron popped from there into that. In redox reactions, that's what's happening all the time, okay? And that's what you're after. Now, very good. So that is a redox reaction. Oxidation reduction occurs simultaneously, so they're called redox reactions. Do you think you're okay with that? Good. Now I'm going to go back again then, and I'm now going to start talking to you about the third term. We've defined oxidation, and we've defined reduction. Let me put them up there for you. Oxidation, can you define it? I hope you're going to tell me oxidation is a loss of electrons. That's the best definition. And then we have reduction. And I hope you're going to tell me that reduction is a gain of electrons. That's exactly what you want. No more, no less than that. That's what you want, and that's it. Now, our third term and definition is an oxidizing agent. You'd be asked to define it. You'd be asked to explain it. Okay? Very important. The third term, an oxidizing agent. Now, basically, the oxidizing agent is the thing that helps oxidation to occur. And that's ultimately what we're after. I'm going back to your notes again now to make sure everybody's okay with this. I've specifically asked you in the notes to define oxidizing agent. Okay? And in my definition, I specifically said what oxidation was. And I'd recommend that to you. If somebody asks you to define oxidizing agent, start by telling them what oxidation is. Put it in context. Okay? I said oxidation is the loss of electrons. The substance which assists with this loss by accepting the lost electrons is called the oxidizing agent. Now, that's exactly what you say, and you get full marks for that. I'm going to say it again to you now. Oxidation, you're asked to define oxidizing agent. Start by saying oxidation is the loss of electrons. The substance which helps with this loss of electrons by accepting those electrons is called the oxidizing agent. Okay, so I'm going to apply that now to our simple equation. There's your sodium again, there's your chlorine, and it went to sodium chloride. Okay, now I'm stressing again to you that equation is not balanced. You'd either have to put a half in front of that or a 2 there and there. Don't go there now. You don't need to balance it. I'm only using it as an illustration. Okay? Balancing is another task which will come up in a further unit. But basically that's it. Sodium and chlorine gives you sodium chloride. Are you okay? And that's what you have there. Now we've come to the conclusion already. Remember now please the Paddy-Murphy theory. That this went, the sodium Na went to Na plus and lost electrons, so that there is oxidized. Okay, and the chlorine then, we said next, the Cl went to Cl minus. For that to go to that, it had to gain an electron, and there you are. had to gain an electron, and consequently that was reduced. I'll put reduced in here. Okay, so that was oxidized and that was reduced. Now we're talking about the oxidizing agent. The oxidizing agent is the substance which helps oxidation to occur. Oxidation is the loss of electrons. The substance which assists with this loss by accepting the electron lost there is called the oxidizing agent. So that, of course, is the oxidizing agent. And I'm going back again now. You're asked to define oxidizing agent. Start by telling the examiner you know what oxidation is. Oxidation is the loss of electrons. Sodium is oxidized. Okay? The substance which assists with this loss by accepting the lost electrons is called the oxidizing agent. And so chlorine is the oxidizing agent. Chlorine is the oxidizing agent. Are you okay with that? Okay, now, finally, we have a statement to make. It's very important. I have it written here. An oxidizing agent is itself reduced. I think I'd prefer you to say something like, an oxidizing agent is always reduced. An oxidizing agent is always reduced. Now, sorry, I can get a bit smart with you at times, but do I need to explain the word always to anyone? Okay, always. There's no exception. Oxidizing agents are always reduced. And there you have it. Now that's it. I'm going to go back on that again. You'll be asked to define oxidizing agent. When they ask you that, you write in your answer, oxidation is a loss of electrons, full stop. The substance which helps or assists with this loss of electrons by accepting them is called the oxidizing agent. That's a definition. Okay? I would knock them dead, by the way, with the final statement, and then I would say oxidizing agents are always reduced. Now, that's fundamental. You need to know nothing else now but that. Okay? Now, we have three definitions at the moment now: oxidation, loss of electrons; reduction, gain of electrons; and oxidizing agent. Now, not a lot of people have a passing knowledge of that, but they're not clear on the concept. Now, I'm appealing to you, please, don't learn this off. In your own words, communicate it, you'll be fine. Don't ever define oxidizing agent without telling me what oxidation is firstly, and you'll find it very helpful. Now, that's in your notes, there'll be no problem with that. Now, can I leave that for the moment? I hope I can. I'm going to go back on it again now, and I'm going to, because I have to do the fourth definition. And the fourth definition is a reducing agent. A reducing agent, okay? That's the reducing agent, and we must define that now. Now, based on what I've just told you, I think you're going to find this okay. I don't think there'll be any issue with it, okay? I think you know what I'm going to tell you next. Reducing agent. In your notes again it is, there's no problem with that, okay? You have it in your notes. Start when you're asked to explain the term reducing agent. Tell them what reduction is. Reduction is the gain of electrons. Full stop. So, the substance which will assist with that gain by literally supplying the electrons is called the reducing agent. That's your answer. It's exactly that, okay? Reduction is the gain of electrons. The substance which assists in this gain by supplying or losing the electrons is called the reducing agent. Okay, and that's exactly it. And I'm going back to do that again for you now. Here we go. I use the same example all the time for clarity. There's no point in you having different examples each time until you have the idea clear in your head. And there you go, right? We came to a conclusion, didn't we already? I'll write this up here now. That's Na plus and that's Cl minus, the Paddy-Murphy theory, okay? That this was oxidized and this was reduced. Yeah, we have come to that conclusion already, yeah? If you want to write them out again, that will be Na going to Na plus, and it loses an electron. Very good. That's what you're after there, right? That will be that, and that will be fine. And the other one then, the Cl, gains an electron and becomes Cl minus. And obviously that electron there and that electron there is the same one. This fella loses the electron, this fella gains it, so there's an electron popping from there to there. Okay, and that's effectively what you need to recognize here. But let me move on now. Reducing agent is the one I'm dealing with, okay? Basically, reduction is a gain of electrons. So the substance that produces that electron, which is that's gaining electrons, that's supplying the electron. So that's the reducing agent, and that's exactly what we want. Okay, that's the substance oxidized. So this is the oxidizing agent. This is the substance reduced. So this is the reducing agent. Now, take it easy now and just get that right for yourself. Someone asks you to define reducing agent, tell them what reduction is. Reduction is the gain of electrons. The substance which assists with that gain by supplying the electron, the substance which supplies the electron is the reducing agent. And of course, the final thing we have to say is that the reducing agent, right, this is gaining electrons, reduction is a gain of electrons, okay? The thing which supplies them, this is losing electrons, so this is reducing agent is always oxidized. The reducing agent is itself oxidized. Reducing agent is always oxidized. Okay, you're okay with that? Now that's very important, is always oxidized. And that's very simple then, and I'm going to just pause there for a minute and go back on that. Oxidation is a loss of electrons, reduction is a gain of electrons. Oxidizing agent, you'll be asked to define it. Tell them oxidation is the loss of electrons, and the substance which helps with that loss by accepting or gaining the electrons is called the oxidizing agent. And please tell them finally that an oxidizing agent is always reduced. Reducing agent, you're going to tell me what reduction is first. Reduction is a gain of electrons. The substance which helps with that gain by supplying the electrons or losing the electrons is called the reducing agent. And the reducing agent is itself oxidized. Now, there you are, 4 simple definitions, and you need to be very sharp on them. Now, please, there's no middle ground in this now. You either understand them, there's no question of learning these now. But whatever I throw up on the screen, if this is my left hand, then this is my right hand. If that's oxidized, that's reduced. If that's oxidized, that's the oxidizing agent. If that's the oxidizing agent, this is the reducing agent. You worry about me, do you? Okay, you know what I'm saying. If you know one, you definitely know the other. Yeah? So will you be careful with that, please? It's very important. And in order to have all 5 definitions together, I'm going to add in, it's belonged to the next section. I'm not doing it, but I'm just going to finish with it now, and I'm going to get you to be clear on it. The last one is oxidation numbers. Oxidation numbers. Now, will you take it, please? That's in your notes as well. It's a formal definition, and we will have to edit it in due course, but I'm just telling you, an oxidation number of an element. Now, sorry, I'll be dealing with this in great detail in the next unit, so don't worry about it at all. But basically, it's a little technique used by the chemist when you want to establish whether something is oxidized or not, okay? So the oxidation number of an element is the charge which an atom of that element has, or appears to have, in a compound. Okay, and there's various definitions of it. Your text has a different one. Be careful you take one on board that you're comfortable with, but that will be it. Okay, it's the charge an atom of an element has, okay, or appears to have, right, in a reaction, and we're going to deal with that. It's a very valuable technique, but it is a definition, and you'll want to be very careful. 5 definitions then: oxidation, reduction, oxidizing agent, reducing agent, and oxidation numbers. And you get plenty of examples. We're going to use a lot of examples on this in due course, but I just need you to be clear on that for a start. So I'll leave that unit now, and we'll start the next unit then with oxidation numbers. Good.